video stories. And the first thing we're going to talk about is the difference between expressions, equations, and inequalities. They all contain, the operation symbols. Expressions contain variables, constants, and operation symbols. The difference between equations and expressions is that equations contain equal signs. They have balance on both sides of the equal sign. Both sides must equal each other. And so that is the difference. You can actually solve equations. You can't solve expressions. You can evaluate them by plugging in the value of a variable, but you can't actually solve for an unknown. And inequalities have these lovely symbols. Greater than, less than, greater than or equal to, and less than or equal to. Parts of an expression. The 2 is called the coefficient because it is in front of the variable. It is being multiplied by the variable. We call that the coefficient. A letter or symbol used in place of a value is called a variable. Anytime you see a letter or symbol that stands in place of a number, that's called a variable. And a constant is a number that does not change. 6 is always going to be a 6 because there's no variable attached to it, and it is not a variable itself. So if you look at 4.2 times m and -7, the constant is the -7 because that's not going to change. The coefficient is multiplied by the variable, so that's the 4.2, or 4 and 2/10. And the variable is the m, the letter or symbol that is used in place of a value. Kim and Jordan are working during the summer to earn money in addition to their weekly allowance. Kim earns $9 per hour at her job, and her allowance is $8 per week. Okay, so I have the hourly rate in green and the allowance in blue. Jordan earns $7.50 per hour, and her allowance is $16 a week. Write an expression that could be used to find Kimmy's weekly earnings. Now this is tricky because people are going to think, well, what's the variable? Is it the hours or is it the weeks? And here's the key. We're talking about 1 week. What is she making in 1 week? So the variable is therefore the hours. So I'm going to let h equal hours. And so if she earns $9 per hour, that's 9 times the number of hours. Per means multiplication. And that should make sense to you, because if she works no hours, if you plug in 0 for h right now, you get no money. If you work 1 hour, 9 times 1 gives you $9 for that 1 hour. But if you work 2 hours, 9 times 2 gives you $18. So that should make sense to you. 9 plus 9, $18. She also has an allowance, and it's $8 a week. Okay, and we're only talking about 1 week, so you only add that 8 in once. That's an expression for Kimmy's weekly earnings. The constant is the $8 because she makes that one time during the week. She can work a lot of hours during the week, but she only gets the allowance once. An expression for Jordan. Well, she earns $7.50 per hour, or times the number of hours, and she gets $16 for her allowance that week, one time during the week. And then what is the coefficient in terms of Jordan's expression? The coefficient is the number in front of the variable, the number that's getting multiplied by the variable, so that is $7.50. So that's just a little bit into how expressions work. And here's another one. On Song Rock's website, each music download costs 85 cents. When you see that word each, that's kind of like per. It's another one that means to multiply. You also have to pay an initial sign-up fee. That's $15. Okay, so if I think about this, the thing that's changing is the music download. So this varies. So I'm going to use a variable for that one. This is constant. You pay it once. One-time initial sign-up fee of $15. So here's how we're going to think about it. 85 cents per download or times each download. I'm going to use D for download. Let D equal downloads. I should say number of downloads. Okay. 85 cents times D, and then of course plus that initial sign-up fee. This is an expression that you could use to find the cost of using the website. If you buy 0 downloads, you still have to pay that $15. It's just $15. One download would be 85 cents times 1 plus 15. So it would cost you $15.85, and so on. Translate the sentence into a formula using function notation. Remember, function notation was from yesterday, and it looked like f of x or g of x, and it would equal something like x squared plus 7. Was one of the ones that we saw yesterday. So they're saying the perimeter, p of n, so they're giving us, the function is p for perimeter, and what you're plugging in is n. And n is representing the side length. It says, write a function to represent the perimeter p of n of a regular hexagon. And how you represent this is that it is the product of 6 and each side length n. Okay, what's product mean? Product means to multiply. So we're going to multiply 6 times each side length n. This works because it's a regular hexagon. All the side lengths are the same, so you could add up n plus n plus n plus n plus n plus n. Or, since they're all the same length, because it's a regular hexagon, you can do 6 times n to find the perimeter. You rent a car, and you are given 2 different payment options. You can pay $25 initially, plus 15 cents per mile, or you can pay $10 initially, plus 40 cents per mile. Write an inequality to show when option 1 is the better deal. So that is when option 1 is less. Option 1 is less. Okay, so you should point it at option 1 because that's going to be the lesser one. And option 1 is $25 initially. That's a constant. Plus 15 cents times the number of miles, because it's 15 cents per mile. I'm going to let n equal number of miles. That's going to be less than the $10 initially plus the 40 cents per mile. And so when you solve that, you will figure out when option 1 is less, and that's when it's going to be the better deal. Okay, number 6. 3 sisters. I'm going to have 3 variables, or 3 let statements. Not 3 variables, but 3 let statements. 3 sisters have ages that are even consecutive integers of one another. Okay, so say I have the numbers 2, 4, and 6. Those are all even, and they're all in order, even and consecutive. And so what I would say is okay, let x equal the first integer. So say x is 2. The second integer, that's the next one that's even, would be 4. So that's 2 more than 2. So I would say x plus 2 equals second. And then you want another sister that's the next even consecutive integer. So that's x plus 2 plus 2 over x plus 4. Okay. Now I'm going to figure out which each of these sisters are. Alexa's the oldest, so this is Alexa. Morgan's the youngest, so this is Morgan. And then it looks like Bethany is the middle child. So if the youngest child is 10, then Bethany would be 12 and Alexa would be 14. If the youngest child is 8, then Bethany would be 10 and Alexa would be 12. Here's how we're going to write the equation. We're going to write it exactly as we see it. I'm going to highlight it as I go. Double Alexa's age. All right. Double Alexa's age. 2 times x plus 4. And I put it in parentheses because it's double her whole age. Not just the x part of it, the quantity x plus 4. Is the same as. That is an equal sign. Okay. Then it's the same as the sum of Bethany's age and triple Morgan's age. Okay, sum means I'm going to add Bethany's age. Bethany's age is x plus 2. I'm going to add Bethany's age to triple 3 times Morgan's age, x. And that's the blue part. Okay, so I did double Alexa's age in yellow is the same as an equal sign, that's in green, and I summed or added Bethany's age plus 2 to triple Morgan's age in blue, 3x. Let's see how we are doing on time. 12:52, pretty good. Write a real-life situation that can be modeled by the expression 5 times x plus 3.5. Okay, so this has a coefficient it has a variable, and it has a constant. Okay. So the way these usually work is you have some kind of initial fee or flat rate, and then you have a charge that you get per item or per mile or per hour. Something is changing by 5 in relation to the number of hours or the number of miles that you have. So one example that we could use here is a restaurant. So let's say the tip that I leave, the flat rate of the tip was $3.50. That's the flat rate. And it was $5 per each appetizer. Okay. What's another one I could do? I could do a situation where it's $3.50 to sign up for a website. Let's say Instagram charges $3.50 to sign up for it. and then say it's $5 per um, like say this is a teacher website. It's $3.50 to sign up for the website, and then it's $5 per worksheet that I get to download. That's a good example of when it's an initial fee and then $5 per each item. You could also say that you could also say that you're a worker and you make $5 per hour plus a $3.50 bonus. So that's kind of going the opposite way. Instead of getting charged, you're making money that way. I think that's all I have for today. We're ending early. What are you going to do with this extra 5 minutes?